And welcome everybody to the Daily Space Weather. We see another coronal mass ejection kicking off here, a large sunspot rising, and some data anomalies. Interesting cosmology stories as well. Starting things out looking at the coronagraph at stereo A. And we see another coronal mass ejection propagating. So this one, once again, is too early to really give you any idea of where it will be directed. But there you have it. Coronal mass ejection happening once again. And this could take hours to completely release from the corona here. It could take most of the day for all we know. And if you're wondering where that's located, stereo A is located at Lagrangian point 5. So there's a diagram of Lagrangian points. These are gravitational equilibrium points where we can put a spacecraft and the spacecraft will rotate around the sun along with the Earth with relatively low usage of fuel. Once again, there is stereo A. It's coronagraph. And it's too early to see anything on the LASCO coronagraphs located here at Lagrangian point 1. We're not even going to show them. Here's a full disk image. And that coronal mass ejection is associated with this filament up here in the northern hemisphere. This filament right up here. And you'll see that kind of vanish right there. And that is that filament beginning its process to exit the corona. It looks like it actually swirled around like this. It looks like it actually swirled around like this before sort of ejecting. It looks like it's headed to the north. But without further data, it's impossible to give you any idea of the direction of that. Here's 193 angstroms. As we see the coronal hole wind stream subsiding, we see some anomalies in the data as well. And we've got another coronal hole rotating in, this South Pole-oriented coronal hole over here. And it's getting a little bit closer to the equator as the solar polar field reversal process of cycle 25 continues. Great view there in 193 angstroms. And we've got some non-traditional solar imagery here. Let's take a look at the view from this one here. This is umbra.nascom.nasa.gov. And here's a fairly current image here at 171 angstroms. I would also note that we've got a beta-class sunspot here in 2811 and a large alpha-class sunspot likely to be named today 2812 rising. So we'll have two additional sunspot groups. And 2811 is beta-class, increasing the probability a bit of coronal mass ejections. So here's 2811, and you can see it does have a trailing opposite polarity umbral group there. And you'll see just peeking over the northeastern limb there, sunspot 2812. And that's just the intensity gram from the SDO. Here is the magnetogram. And you can see the opposite polarity of those umbrae with 2811. Only one umbra so far associated with the new rising sunspot 2812, which will get named today. Here's a diagram of the solar system. There's where things will be in a week. It looks like a full moon is 1 week away as we have a gibbous waxing. Here's a star chart. If you need to pause it on this, feel free. And we see, I believe, Saturn rising ahead of the sun there. If you've got a clear easterly horizon, you may see that. The 10.7 centimeter radio flux, the 2,800 megahertz radio flux emissions from the sun, they come out of the outer chromosphere and the lower corona. those radio photons. 77 is the current radio flux number. 77 solar flux units. Here's the 1-year chart of that from Solon.info. The sunspot number here is in red, and the 10.7 centimeter radio flux, 2800 megahertz radio flux, whatever you want to call it, is up here in black. As cycle 25 is taking its good old time to ramp up here. There you can see cycle 24 in the beginning of cycle 25. By the way, if you're wondering where cycle 25 began, it was right around here in November of 2019. And there's the radio flux. You can see how proportional the sunspot number and radio flux are. So expect the radio flux to come up. Let's talk Fagradalsfjall. I spent a long time watching Fagradalsfjall yesterday. And if you're wondering where it's located, well, that's where it's located. It's not far at all from Reykjavik, Iceland. And there you can see that complex there. I believe this is actually the peak. So Fagradalsfjall continues to erupt, and there's an image of it. We're going to actually show you a live webcam momentarily. Suwanosejima in the Ryukyu Islands also exploding, flight level 040. It's a 4,000-foot ash plume above it. And let me just check the life of the stream here before we continue on. Everything looks just fine. Mount Ibu in Indonesia also exploding. 7,000-foot ash plume above it, 14,000-foot ash plume above the East Javan volcano Semeru. And now Kerinci on the Isle of Sumatra back on the list. A 14,000-foot ash plume above it. Flight level 141, 14,100 feet is the altitude of the top of that ash plume estimated. Pacaya, now back on the list again in Guatemala, that's exploding, flight level 140. It's a 14,000-foot ash plume. Fuego in Guatemala, 16,000-foot ash plume above it as it explodes, and we're unable to detect whether or not Sabancaya is erupting. Please do not pole vault the caldera. So here's Fagradalsfjall. It looks like we've got some volcanic gases in between the camera and the caldera. And again, we spent a long time watching this one yesterday. The title of the video is Volcanic Eruption in Iceland, and it is spectacular. You may find yourself transfixed, spending a long period of time staring at Fagradalsfjall. It makes your campfire look hilarious. So I think we're about a half mile away, and actually if you see people are only going to be about this big, because you may see people down here at the edge of this lava flow. People are going to be about that size. So that'll give you some idea of the scale of this. And not surprisingly, traffic up to the caldera, up to this area here, has been cut off, as we don't want to see anybody consumed by a lava bomb. Ongoing volcanic eruption with a fantastic webcam. Volcanic Eruption in Iceland is the title, from something I'm not even going to make an attempt to pronounce. And I would invite everybody to check out our own website as well, smAsho.com. We saw the writing on the wall a couple of years ago and decided to go out on our own and create our own .com. smAsho.org will redirect you. And today's featured product is the I Survived a Global Pandemic So Far shirt. And I'm actually wearing one here. This is a slightly different design, but this is the basic design of it here. And you can link to that from our homepage. There's also a bunch of other merch there. Are you safe yet? There's a bunch of other merch there as well. And that would be the smAsho store. There's also a smAsho merch and a Smash store there. More on that later. Not putting the more on into more on that later. No major earthquakes over the past 24 hours. Let's scroll up the list. There's a deep quake at Bolivia. a 5.0 magnitude at 181.8 kilometers depth. Another deeper quake at Bolivia, a 5.2 at nearly 600 kilometers depth, one of the deepest we've ever reported on the South American continent. It's pretty far inland too. Let's take a look at that location real quick. If it loads. Here we go. You can see quite far into the continent there. In a pretty mountainous region was that nearly 600-kilometer deep quake in Bolivia. 4.4 magnitude, 240-kilometer deep quake in the Banda Sea. There's a location of that one just north of Australia. Another deep quake in Indonesia. And just scrolling up the list here, 5.1 in Colombia. And there's a shallow quake in Hawaii. Let's check the location of that one. It's located in Volcano, which is actually east of Mauna Loa. And there you can see a little more activity there on the eastern flank of Mauna Loa. We've documented quite a bit of those in the last few videos. Another deep quake in South America, this one at Argentina, a 4.5 magnitude at 185 kilometers, and another deep quake at Bolivia, a 4.4 at 189 kilometers, moving on. And we saw one decent solar flare here, not quite a C-class, an upper-level B-class flare. Peak flux happened at 1:30 this morning, Universal Time. No proton strikes, no surprise there. We don't see any major coronal mass ejections expected to strike the magnetosphere or make it down to the GOES 16, where it makes its measurements at about 300 kilometers of altitude. Here's the GOES magnetometer over the past 3 days, and we're seeing these spiky sawtooth patterns. That's a result of a high-speed coronal hole wind stream, which has not yet subsided. Here's the magnetometer scenario for the heliospheric current sheet. And you can see the Earth solidly in a South Pole-oriented current sheet there, where it will remain for the foreseeable future. Keep in mind this data is about an hour and a half old. And if you're wondering where it's derived from, it's from 51 ground-based magnetometers here on planet Earth, as well as one at Lagrangian point 5 at stereo A, which is this little plus sign here, and stereo B at Lagrange point 4. I meant to say L4, not LB. There we go, L4. Yes. So that's the Gong 2 data. Here is the line of sight coronal hole plot, and you can see another South Pole-oriented coronal hole rotating in here. This one also reaching up toward the equator. I think that one's actually become trans-equatorial there in some of the final frames. Let's bring up the last frame here. And you can see this is now officially a trans-equatorial coronal hole. And we'll keep you posted on when we expect to see the wind stream from that. It'll be in like 5 days. Here's some more data here from the Integrated Space Weather Analysis Center. And you can see Sunspot 2811, how it's beta class. And you can see a bunch of filaments here, some of them disappearing, some of them remaining around the eastern limb. KP index currently at 2, and we see some anomalous data that we're going to get to in a moment here. And you can see the subsiding of that coronal hole wind stream. We made it into briefly geomagnetic storm conditions for about 6 hours yesterday. And 2 days ago, we reached a G2 class geomagnetic storm of a KP6 for a few hours. Next, the real-time solar wind, and it's showing some likely errors here. So we're seeing some errors, likely errors in the solar wind. You see these orange bars down here? These are error suspects. So the system does not believe that the data was actually a solar wind density suddenly all the way down to as low as 0.14, 0.12 protons per cubic centimeter, not likely to have suddenly dropped off that much and then come back up to this baseline here. Anyway, current conditions are about 6 protons per cubic centimeter for the density and just under 600 kilometers per second, so an increased solar wind speed continues from that coronal hole system. And those anomalies have created a bunch of anomalies here in the space weather modeling framework. So this is probably a bunch of bunk data. We're going to show it anyway. And it's got nothing to do with Nibiru or ellipsoid fields created by Jupiter and Saturn or any other nonsensical stuff. It's created by the sudden drop-off in the solar wind density data, again, likely erroneous in nature, and that affects the space weather modeling framework because the solar wind information is one of the most important parts of these space weather modeling framework models. So here's the density. We just showed you the velocity. And each one of these geospace magnetosphere movies represents 4 hours of data. For all you new viewers out there, thanks for tuning in. Here's the pressure. And the pressure will look a little bit more logical. You do see it drop off there suddenly and then kick back up. And then drop off suddenly and then kick back up. Likely to be associated with that sudden drop-off in solar wind density, which is probably, again, erroneous data. Here are ground magnetic perturbations, and this is not going to be any more definitive. This is going to be all over the place most likely, and you do pretty much see that. Let me advance that to where it was. And we're going to show you the global view as well. This is also 4 hours of geospace delta B changes in the Earth's B field. Here's the flattened map. And we show this one daily, since we are living a geomagnetic excursion. Welcome to the Neo-Renaissance, folks. Welcome to the Neo-Renaissance, where kooks and fraud are promoted. All right, so we are streaming live right now to Twitch. It's twitch.tv/smAsho. They've got a great mobile app as well. It'll alert you when we do live streams. We don't always stream live to Twitch. We also do live streams to YouTube. We've also got videos on BitChute. More on that momentarily. Thanks to our followers over at twitch.tv/smAsho. Thanks most of all to our patrons, as we make just this side of nothing to put the videos on YouTube. And we've watched our subscriber count stagnate between exactly 1,740 and 1,750 subscribers for pushing 3 weeks now. So thanks to our patrons, as we have some idea of some income associated with the videos. Patreon.com/smAsho if you want the most early alerts from anybody on Earth. And that brings us to our mission. You can read more about the mission at smashomash.com/forum/mission. And other interesting things to read at the forum as well. smashomash.com/forum. Number 3 is to connect and consult with media organizations to multiply our reach, which is why we have a YouTube channel. youtube.com/smashomash. And if you're viewing on YouTube, please don't forget to press like and subscribe. And please share with your friends and foes, your science noobs and your science pros. There's probably something for all of them on the channel. And thanks to our loyal viewers as well as new viewers. Check out our playlists as well, youtube.com/smashomash/playlists. We're also on BitChute. Maybe check out our most viewed video over there. COVID-19, a disease caused by coronavirus cured via hydroxychloroquine and azithromycin. Yes. That was probably too fast to be transcribed on purpose. There's also a large coronavirus thread. Check out our playlist about the coronavirus, the COVID Chronicles. The COVID Chronicles, folks, then and now, looking at what was going on 1 year ago and what's going on now. And here's what's going on now in cosmology. It's today's cosmology segment. Are you familiar with Eta Carinae? Well, Eta Carinae is an interesting, extraordinary star that has fascinated mankind for decades. It's surrounded by an expanding homunculus nebula shaped like an hourglass. The nebula was expelled in an energetic explosion called the Great Eruption that occurred in the 1840s, and it became the second brightest star in the sky and was visible to the naked eye for over a decade. Here's what the nebula looks like, and this is an article from today at scitechdaily.com. And what you're looking at here is a great example of toroidal and poloidal systems. So this system here around the equatorial region of the star in the center of the disk, that is the toroidal region, the torus. This is the torus that everybody's obsessed with when they're talking about things like, I'm not going to say the EU word. I'm not going to say it. And these are the poloidal regions. And what's likely going on here, folks, is that you're likely looking at the precessional wobble. So this is probably based on the axial tilt of the central star. And as this tilt wobbles back and forth, it creates this circle as the axis tilts over this way and then over this way. And when it's the most in line with its magnetic field, we get the most output from that poloidal field. If you want to read more about Eta Carinae, again, it's at scitechdaily.com. Let's pick a random object using our quantum number generator. Today's random number is 774. And I'm not sure if we covered that one before. Let's check it out. 774 is Maxi J1807 plus 132. Is it a neutron star? Check it out. It's got extremely variable outputs. It was emitting X-ray up until about 2018, and then it stopped for a couple of years, and then it kicked back up in 2019. It's currently emitting X-rays again, whatever it might be. Let's take a look at it visually. Let's see if we can find any more information about Maxi J1807 plus 132. And we've got a phys.org article about it. It's an X-ray binary, folks. So it's a binary star system here, undoubtedly located in the Milky Way galaxy. So here's an article. This one is from December 1st of last year. So it must be an extremely variable system here. It is a low-mass X-ray binary, believed to be a white dwarf and a neutron star. And I'm not sure if we'll be able to see any visual analysis of this or not. Check it out. There's an article about Cygnus X2, folks. But anyway, that's an extremely variable system there. And let's see if we can see any imagery of this one. Thermonuclear bursts. And I don't want to spend too much time looking for this in the Daily Space Weather video. If you want to learn more about it, look up Maxi J1807 plus 132, the low-mass X-ray binary. Let's talk about the Orion Nebula. And what you're looking at is Orion here. Here's Orion's belt. And here's Betelgeuse. And you're looking at a composite image here. The red portion is hydrogen gas. You can see this crescent-shaped curve here of hydrogen gas associated with the Orion Nebula. Also this string of main sequence stars right here. And we've got some close-ups of that region as well. This is another SciTech Daily article. This one entitled, Astronomers Puzzled After Hubble View of Torrential Outflows from, quote, infant, end quote, stars blows holes in current theories. Is this because stars are electric? Well, most certainly not. However, look, another example of the toroid versus the poloid. Here's the poloid fields. And here are the toroid fields. And the distinction between the two is going to solve a lot of problems when it comes to cosmology, and it's going to further those willing to listen's understanding of how stars seem to work. So here you've got an area that you see a great bow shock right here. It looks like a pulsar wind nebula almost, where the poloidal fields are being bent. And we won't continue on too long with this. I'm just going to let the article scroll here. Feel free to pause. Again, this is from scitechdaily.com. And that's a composite from the Hubble and Spitzer space telescopes, the Orion Cloud Complex. And the fact of the matter is, folks, we do not know how stars are born, or if they're born, or if they die. We just simply don't know that stuff. And there's a great close-up of that line of stars that are in a quite concentrated line here. And it's probably because the lining up of their poloidal fields, and I won't go any further into that on today's cosmology segment. And let's move on. And thanks for leaving a comment, Amtony19956, and you've earned yourself a timeout by trying to sell me viewers, something that is never going to happen. Don't try to sell me viewers. It's not going to be a thing. Not buying viewers ever. And that's today's cosmology segment. Let's get back to current data. Here's a one-year chart of the electron flux as measured by the GOES 16. You can find that chart at solon.info/solar as well. And we've just moved into electron warning territory here. So once again, great timing, folks. A coronal mass ejection happening as we do the daily space weather video. Just going into electron warning mode here. Shout out to our patrons. Here's the forecast model for electrons, and we're expecting an uptick here. I would tend to agree with this, especially once that coronal hole wind stream subsides. It looks like we're seeing an uptick in the electrons a little earlier than expected. The green boxes are the forecast. The yellow diamonds are the observation. Here's the air column up to about 12,500 miles of altitude. This is the inner Van Allen belt, essentially in a flat visualized form for Earthlings. It'll show you where GPS errors are likely to occur. And most GPS errors occur around the equator at noontime, folks. So not too anomalous there, and we see less anomalous areas of electron flux when we see higher readings as opposed to during coronal hole wind streams. So here's what we are looking at. You're looking at approximately this entire air column here, the whole air column up to the thermosphere, up to your geosynchronous GPS satellite altitude. Here's the ionosphere. This is a full day of data, and each second here represents 15 minutes. And we'll let this play through. It's courtesy Australian Government Bureau of Meteorology. And for anybody attempting to use the ionosphere to forecast earthquakes, this is not going to work out for you because you're looking at a resolution of 1 megahertz here. And the alleged variations in the ionosphere are more like 0.01 megahertz. So we're nowhere near the resolution required. However, if we see any large anomalies in the ionosphere, they will show up. And we see some charge ups here over South America, making it up to 14 megahertz. And when you see those red blobs, that is an F flare. When you see anything besides red, it's an F2 or an F3 or an F4 layer. Hope that gives you some insight into what's going on in the ionosphere. A bunch of ions vibrating at specific frequencies. There's the current image from 9:15 Universal Time. And here's a diagram of the atmosphere, this F over here, that is the F ionosphere layer. Feel free to pause that if you must. Next, doing some meteorology stuff, here are the jet streams of the Western world. And let's take a quick moment to look at surface winds. And there are surface winds. Man, barely any winds over the entire continent of South America. Check it out. Almost no wind over the whole continent. Tripled up jet streams over the North Atlantic as well. Here are the jets of the east. The jet streams of the eastern world. Pretty incoherent in the southern hemisphere, doubled up over the northern hemisphere. And some big bends over the North Pacific as well. Looks like some warmer weather expected in the North Pacific. And this time we brought up windy.com's satellite imagery. Just give that a moment to initialize. It's quite good. I like it. And it should animate. Anyway, that's 2 hours of satellite imagery there. And this line over here, that's caused by the day-night terminator. And that's because the system has to transition between shortwave radiation and visible satellite. Continuing on. We normally show a pressure forecast there, but we like to switch up things a little bit each day. Next, we're on blitzortung.org, and we see some quite active lightning here off of the coast of South Carolina, it looks like. No terrestrial lightning in the U.S. right now. Blitzortung, a real-time lightning map, and we usually use lightningmaps.org. Let's see if their servers are back. Lightningmaps.org's servers burned, and it looks like they are back. We'll switch back to lightningmaps.org, and we've done it live. Next, looking at a shortwave radiation map of the U.S. to show us where clouds are likely to be. Some swirling systems here off of the coast of South Carolina are kicking up some lightning, most likely. Here's a water vapor map to help show that. And you can see some rapid cloud nucleation happening right in this region here. And a bit of a counterclockwise rotation happening there. And a massive pressure gradient. Also an atmospheric creek moving into Texas, as you can see there. It is associated with some clouds, some upper level and some lower level clouds, as you can see there. Great view of that. And here's a U.S. Doppler radar map. Some more snow falling in Central Colorado. Central Colorado, the source of a lot of hot air. You may have heard hot air coming from Colorado. I certainly did. And then I stopped listening. Next, we've got some more imagery of Sunspot 2811 and Sunspot 2812. 2812 is this one that's barely over the limb. And this is 94 angstroms, which is one of the ionized states of iron and the UV emission spectra of it. Here's 131 angstroms, which is one of the crowd favorites, I'm told. How about 304 angstroms? This one's ionized helium. The last one was another emissions, another ionized state of iron. This is ionized helium. Fantastic view there. And here's 171 angstroms. Another ionized state of iron, as iron wants a lot of electrons, folks. And it's about time to close this thing out. And we're going to make sure we have the latest data here. We're going to close things out on the Gong H helium alpha. The Gong helium alpha at Lermouth. And you can see some filaments up here. You can see some brightening. I believe the B-class solar flare came out of this active region, formerly Sunspot 2810, now decayed to plage. Some filaments down here in the southwest as well. And thanks for tuning into the Daily Space Weather, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, but if you do drink, don't drive. And since it'll never be now again, may that solar wind be at your back.